Hello, my name is Kenneth, and in this video, I will walk through my work on assignment 1 for COMP3132, where we explored the Fashion MNIST dataset and built a neural network using Keras. Fashion MNIST is a dataset of 6,000 training images and 10,000 test images, each representing a fashion item like t-shirt, trousers, dresses, and sneakers. Unlike the classical MNIST dataset of handwritten digits, this is slightly more complex, which makes it interesting to analyze and classify. So let's go through question 1. Here, I completed questions 1 through 9, which involves exploring datasets. So in question 1, I checked the dimension of training images, train label, train images, and test labels. Train images are 60,000 by 28 by 28. Test images are 10,000 by 28 by 28, and the labels are one-dimensional array. In question 2, I verified the lengths of train label and test label, confirming 60,000 and 10,000 respectively. In question 3, I displayed sample labels from both training and test sets to see the class distribution. In question number 4, I showed the digital content and pixel values of image index 5 and the training dataset. In question 5, I plotted the image at index 5 to visualize what a pullover looks like. Then in question number 6, I identified the label for index 5 is 2, which corresponds to a pullover according to the class list. In question 7, I displayed the digital content of image index 500 in the testing dataset. Next, for question number 8, I plotted the test image at index 500, which is also a pullover. Then for question 9, I confirmed that the label for index 500 is 2, meaning a pullover. Then for question 10, which is in the very first, we imported models and layers from Keras library along with NumPy and Matplotlib. Then again, when we go for question number 11, here we defined a sequential model and called it my network. Then in question 12, I reshaped the image from 28 times 28 to one column with 784 neurons through flattening. Then in question 13, I normalized the images by dividing by 255, converting pixels value from 0 to 255 to 0 to 1 range. In question number 14, I added a hidden layer with 512 neurons using the ReLU activation function. Then in 15, I added another hidden layer with 128 neurons also using the ReLU activation. Next, in question number 16, I added a final output layer with 10 neurons using softmax activation. And here, we use softmax activation because it converts the raw output values called logits into probability distribution across the 10 classes. This ensures all output sums to 1. And each value represents the probability that the input belongs to that class. The neuron with the highest probability is predicted class. This makes the output interpretable as probabilities, which is essential for multi-class classification tasks. Next, we go to question number 17. Here, I compiled the model with 2 different options, option A and option B. In option A, optimizer equals to Adam, loss equals to spare categorical cross entropy, matrices equals to accuracy. And then in option B, optimizer equals to RMS prop, loss equals to categorical cross entropy, and matrices equals to accuracy. For option B, I converted labels to one-hot encoding since categorical cross entropy requires that format. Then in question 18, I trained both the models for 10 epochs using the fit function. Here, model A with Adam optimizer achieved a training accuracy of 91.57% and test accuracy of 87.99%. Model B with RMS prop achieved 91.20% training and 88.12% test accuracy. Both performed similarly, with model B showing slightly better test accuracy. Now let's come to question 19 and 20. In question 19, I compared Fashion MNIST with the classical MNIST dataset. Fashion MNIST is more challenging because fashion items have greater visual complexity, including patterns, textures, and style variation, unlike simple handwritten digits. While MNIST often achieves 97 to 99% accuracy, Fashion MNIST typically reaches around 85 to 92%. Some classes such as t-shirt, top, and shirt are also visually similar, making classification harder. Then in question 20, I analyze the accuracy differences, where the lower accuracy in Fashion MNIST is due to the interclass similarity, high variation within the same class, complex visual features, and the limitation 28 times 28 grayscale images, which reduces the fine details. Because of this, Fashion MNIST serves as a more realistic benchmark than MNIST. Then in question number 21, I evaluated both models and analyzed overfitting. The model A showed a training test gap of 3.58% and model B showed a gap of 3.08%, indicating moderate but manageable overfitting. Test accuracy about 88% suggests good generalization of Fashion MNIST. So in conclusion, I completed all 21 question building and training neural networks to classify Fashion MNIST images. Both models achieved around 88% accuracy, demonstrating good learning capabilities despite moderate overfitting. This assignment helped me understand datasets exploration, pre-processing, model building, training, and evaluation in Keras. Thank you so much for watching my presentation.